How can we effectively use large language models to create a high-level task planner for robots that can interpret and execute contextually appropriate tasks based on human interaction? Hi, my name is Kip, and I'm a student at Choate Rosemary Hall. My curiosity has always driven me, whether when I was 6, trying to explain to my dad how the Northern Lights worked, and after I had binge-watched hours of Nova documentaries on end, or exploring the intricacies of soft robotics and watching hours of Boston Dynamic videos on YouTube over COVID, or even designing innovative and accessible 3D printable prosthetics for disabled dogs in my sophomore year of high school. This curiosity brought me to Yale University's Interactive Machines group, working with Nathan Tesoi, a PhD student, where I integrated large language models like Llama 2 and Wizard with a social robot called Arabato. This wasn't just about building a robot. It was about wanting to apply my knowledge from classes into real-world experience. I worked on developing a high-level task planner that uses natural language to parse viable actions for the robot to perform, which included facial expressions, head tracking, speech, and movement. This project allowed me to explore the hypothesis of mind-brain dualism. If the human mind and the brain are different, and if the LLM represents only the brain, what is the limit of the LLM relative to a human? I analyze robot responses for parsability, separating contextual understanding, interactivity and adaptability, and implementation and limitations as focuses. However, context became an issue. Since the LLM by default is stateless and doesn't remember previous fragments of the conversation, I had to supply it with all the context so the conversation could continue. Crucial to achieving this, I incorporated a robot memory for context-based interactions. This involved initializing an empty history for each actor when they are loaded, then appending the conversation history to the prompt before querying the model, then appending the model's response to the history and truncating the history from the beginning if it exceeds the variable max history characters. I wanted to do this because I'd never seen something like it done before, and also because unlike traditional classroom settings, where answers are known by the instructor, coding and mechanical engineering through social robotics presented a landscape where solutions were discovered. This uncertainty fueled my creativity, pushing me to build upon what I knew and eagerly learn what I didn't. And as the issues became more and more complex, my solutions rose in technicality to meet them. So it's not just the chat robot. It's a lesson. My enthusiasm led me to co-lead the CAD Club as a part of my high school robotics team. I taught new students the basics of CAD every Sunday and the wonders of the application. I also incorporated a design element where student members got to take their own designs for a part and then 3D model them in Onshape. To facilitate their learning, I designed creative examples. This passion for community and change-making led me to mentor a rookie-first robotics team, Team 9193 of Waterbury. They faced budget cuts and the pandemic challenges, but I was determined to support them. So over my junior year, we provided supplies, coding assistance, and technical guidance to the team. I set up meetings with them, assisted with any questions they had, and was the primary facilitator of mentorship and mentored interested students through CAD designs for their robot. I built an example intake for them to use. By implementing creativity, my knowledge, and a little bit of fun, I was a crucial resource for the new students to flourish in robotics. This journey has been more about just robotics or technology. It's about the impact of innovation and the power of teaching and the importance of community.